Hello and welcome to today's Omdia webinar, Multi-Technology Discussion to Enable Advanced Broadband Networks for All, sponsored by the World Broadband Association, or WBBA for short, and broadcast by Informa Tech Target. My name is Michael Philpott and I'm the Senior Research Director with Omdia, and I'll be your moderator for our discussion today. If the socio-economic benefits of broadband connectivity are to be maximized, then it's imperative that there is a continued investment in fixed broadband networks so that all households and business premises can eventually be connected to advanced fixed broadband services. In this webinar, we will discuss the best technology choices for operators and regulators looking to create a strategy for advanced broadband networks for all, including a best-of-breed evolution path to a full end-to-end fiber society. On that note, I'm excited to introduce our speakers today. I'm joined by Dr. Marcus Brunner, WBBA Working Group Chair and Chief Expert for Enhanced Broadband at Huawei Technologies Switzerland, Gavin Young, Head of Fixed Access Center for Excellence at Vodafone, and Mohamed Amin Benzian, Vice Chairman at Algeria Telecom. Thank you all for joining us today. Before I hand it over to our speakers, I just wanted to remind our audience of a couple of things. This webinar is interactive. At the bottom of your screen, there are buttons that you can click to learn more about today's speakers, download a copy of the slides, share this webinar via social media outlets, and participate in the Q&A session that takes place at the end of our presentation. You can also use the Q&A area to let us know if you experience any technical problems, and our team will do our best to assist you. Okay, before I hand over to our main speakers, I just wanted to give a brief introduction for what we mean by enabling an advanced broadband network for all. Because ever since broadband services were first launched, the focus has always been and very much focused around speed. And what has that meant as markets became more and more competitive is that operators just offered more and more speed for the same and sometimes even less price. And that has led to an exponential growth in the availability and the penetration of broadband speeds, going from where we had a situation of just 0.1% of broadband subscriptions on the consumer market of over 1 gigabits per second back in 2014 to 27% by the end of 2024. And we predict just under 55% by 2029. And this has, of course, also increased the average broadband subscription speed, not quite the same as what we receive at their end devices, but at least what we're subscribing to, going from 20 or just under 20 megabits back in 2014 to over 500 megabits at the end of 2024 and over 1 gigabits per second by 2029. And in the first generation of the internet, it's quite reasonable that there's so much focus on speed because all the applications, or the vast majority of them, were download in nature. We downloaded software, we downloaded media files, and indeed, for many operators around the world, that's kind of how they explained broadband speeds and acronyms such as megabits per second, etc., down to the mass market consumer in terms of how long it took them to download certain media files, etc. But as we move to the next generation of internet applications, then will become increasingly interactive in nature. And this means that it's important that we have a focus on different types of metrics other than speed. Speed will remain important, but other metrics such as latency and reliability and consistency will come in nature, because not only will we need high speed services, we'll also need low latency type services and low jitter, not just some of the time, but for the entire session, if that session is going to be delivered in a high quality way. And that's why the World Broadband Association set out its next generation broadband roadmap to define and set out how the broadband networks should evolve through the different generations, not just in terms of ultra enhanced speeds, but also in terms of the network intelligence, the ultra reliability and consistency, as well as other metrics such as sustainability and greater sensing capabilities. The organization recognized that the optimum network technology to maximize in all these metric areas would be an end-to-end fiber network. But it also recognized that it will be many, many years to come before all premises are connected to the fiber broadband network. Indeed, by 2030, on a global basis, under 50% of residential households will be connected to fiber. And indeed, just under 40% of them will either be unconnected altogether or will be simply relying on smartphone access for their internet access. And you can see from the chart on the right that these percentages can differ significantly from region to region. And within regions, of course, you have countries that, again, where you get massive differences between the types of connectivity that consumers have. And what this will mean is that we just head to a second new digital divide based on not just being connected, but what type of connectivity those consumers and those businesses will have access to. And before I hand over to our main speakers, which will go into that in more detail, I just wanted to point out that it's not always just about technology. There's a lot of focus around technology and around how much it costs to get technology rolled out there. But there are other barriers to take up as well, and pricing is certainly one of the biggest. You can see from the chart on the left that there are many countries around the world where we have very good fiber to the home coverage, in many cases above 70%. What that means is that the 70% of households could get access to fiber connectivity if they wanted to. But in many of those cases, less than 40% are actually connected. In some cases, less than 20%. And that often comes down to pricing strategy. And this is specifically critical, of course, in emerging markets where pricing is more important. And what we see there is that although broadband services are available, they often price very much as a premium, and the advantages of fixed broadband are not always marketed very well. The services often come, with strict usage limits, limited speeds, include expensive setup costs, and it's no wonder, therefore, why consumers in those markets continue to just go with a mobile service because it's just more cost-effective option for them. But also, it is also important once consumers get connected to fixed broadband that we then continue to push them towards a fiber broadband connectivity. What we're showing here is just one country, and I know that the chart can be quite complex because even in a single country, you get different types of operators operating in different areas of the country with different strategies. But if you start to break this chart down into kind of the value, the mid and the high end services, you can then start to see some trends. And what the trends are showing is that it's only at the high end where the operators are pricing the fiber technologies more competitively. You can see in the mid and the value ends, fiber is often priced just to compete with the other technologies or even actually priced at a premium. And what this can mean is that we operators are deploying the fiber networks to all, and yet only appealing to, say, the top 10%. And that really holds back then penetration in those markets. And with that, I'll hand over to our first of our key speakers, and I'll hand over to Marcus.
Thank you very much, Michael. So basically, we now dig a little bit into the different technologies. And I try to explain, based on the white paper we are published and which is downloadable, basically how we can move from a multi-technology to an all-fiber networks. As a start, basically, it is showing the general trend in the global broadband industry. You see in this chart that starting from 2000 onwards, a lot of different technologies were used and deployed. When we look at today, 2025, the majority of fixed broadband subscriptions is today on fiber. But there's quite a number of different technologies, and I will come a bit more detail into all these different technologies because we really need to master a multi-technology scene at the moment. The final goal is naturally going to fiber, but there are various steps to go there, and there are different strategies going there. And depending on the investment capabilities, different technologies might make more sense depending on the strategy. So I try to explain a little bit on that. The first thing is that, and Michael was already touching upon that, there's a great regional difference. If you look in that chart, there are various regions of the world which have different levels of completely unconnected people. You have a set of subscriptions which are mobile-only broadband. Then there are like non-fiber broadband, that means all different types of technology, and then fiber broadband. So depending on the region, I mean, it's a very, very diverse set. That comes because there are various technologies in the market. Deployments are going on at different scale, different time scales, and so on. So we need to take that into account. It's not like one size fits all here, and we need to look at it a little bit more differentiated. For doing that, in the white paper, we basically have done a summary of the main broadband access technologies, and they were more explained what are the strengths, weaknesses, opportunities, and threats on a per technology basis. And I distilled or tried to distill here, like in my opinion, the most biggest point or a topic for different technologies. So on the left side, we have the class of DSL, XDSL type of technologies. We have the cable, like cable TV, coax type of technology. We have the fiber to the premises technologies. We have the fixed wireless access, like using a mobile infrastructure for fixed services. And we have the satellite technologies, which came in lately quite big. So looking at the strengths and weaknesses in DSL, naturally it's the use of the legacy infrastructure. In countries where copper telephony has been deployed, using the old telephony lines is a very good thing to deploy DSL. Naturally, the DSL technology is sort of a little bit on end of life in terms of the speed. At one point, one needs to switch to different technologies. So the speed in DSL is definitely limited. There is naturally opportunity for this, specifically in areas with low broadband penetration. So, and the threat is that the copper infrastructure is really being replaced. So if you run things on copper, other competitors might come in and go with fiber there. On the cable side, so with the hybrid coax fiber being capable of gigabit broadband speeds, that is naturally much better than DSL in terms of speed. Now, the weaknesses of that technology is more that it's a shared TV channel. It's less efficient, specifically for upstream. Upstream is always a little bit of a problem with the cable technologies. Naturally, there's an opportunity specifically for TV operators to provide broadband. So if TV operators are already in the market and are easily able to provide broadband on the existing cable infrastructure, is a very good opportunity. And the threat is that it's very unlikely that new developments in that space is happening. I can say here from the standardization and the technology development side and the cable industry, they are also looking how to move to a fiber these days. Fiber to the premises, it's really like laying fiber to the end users, is the most future-proof. It's very cost-effective when it is deployed. And the key is here when deployed. That's also exactly the weakness. It's very expensive to deploy because you need to do a lot of groundwork like digging and so on. So that's the massive weakness on that. The opportunity is that the migration to fiber may expand the footprint. So depending on the markets and regions, that might be an opportunity. And the threat is due to the digging and the time to market for fiber, other technologies are faster to market. So that's sort of the threat on the fiber side. The fixed wireless access is the strength is definitely very fast to deploy when mobile capacity is available. And the weakness is it's shared spectrum. So you share the spectrum of the mobile infrastructure with fixed deployments. What it means also is you might need to potentially upgrade the mobile network if you need the capacity on the mobile network for that. So it's very fast to deploy, but has its downside as well. Opportunity are definitely in greenfield and fast offering of broadband services. Specifically, operators not in the market at the particular area, it's very easy to start offering broadband services over FWA and enter the market there very quick. So the threat is naturally that the fiber to the premises offers higher speed and higher quality. All numbers today show that fiber to the premises has best quality over like the whole day, independent of weather and independent of many other things. Then the last technology I would quickly like to mention is satellite. I mean, the very good strength of satellite is naturally you have a huge coverage. One satellite can cover quite a large area of the world. The weakness is the initial deployment is very high in cost, and it's basically sharing by many users. If you have a large coverage, if all the users in that area are using the satellite, it's very difficult to use that. The opportunity is naturally a very good option for rural areas, and then there are many business and government use cases which rely more on satellite, because you have like immediately countrywide coverage with satellite. It's relatively easy to do. The threat is that all the technologies are either cheaper or faster or both. Many times it's actually really both. Really depends a little bit on the subscription offerings on the satellite side. So that's a very quick summary on the main broadband access technologies and assessing them a little bit in terms of the different strengths and weaknesses. So moving on, as said, all these technologies have their place. And in the white paper, we basically try to show how we can evolve to an all-fiber network. We propose here like 3 steps, and naturally some of the steps or phases can be skipped, but it's in general, the phase 1 on the very left side is basically you try to focus on get a large coverage quickly. That's where some of the non-fiber technologies might be very suitable. You get broadband penetration quite quickly. And broadband here means doesn't matter what technology used. It can be wireless or wired type of technologies. So if you want to get coverage, that's the way to go. Phase 2 is focusing on driving fixed broadband connectivity. So basically that's about rolling out fixed broadband access technologies adapted to the area. I mean, depending on the area, some technologies might be better suited than others. I said some in the urban area might be suitable to use different technologies than in cities. And then the last phase 3, is really the focus on continued broadband investment towards gigabit or multi-gigabit societies. So the current talk, at least in the industry and the forward-looking people, is talking towards the 10 gigabit society. Having multi-gigabit is now people need to think about that. That's largely doable with fiber and less doable with other technologies. Then on the roadmap looking forward, all these technologies which I mentioned, they have a roadmap towards other like higher speed options. In the DSL space, there's the XG-Fast, DOCSIS, that's a cable technology, DOCSIS 5 is discussed. Fiber to the premises, the 50G PON is deploying today. The 200G PON is in discussion. And fixed wireless access, naturally 6G mobile technology is thus discussed for those. Satellite doesn't have that much of a roadmap type of discussion going. And then the expected development is very market dependent. On the left side, I put the chart on the highly developed markets, and you see it the highly developed market, it goes all fiber. It's towards like 95, 98% fiber deployment, and the other technologies are getting lower. They're still there and they're still used, but have a low size market. However, in the more emerging markets on the right side, you see that fiber is the largest part today, and is expected to be the largest part also in the future. But as said, I mean, depending on the markets and the status where operators and societies are, other technologies are heavily used. And that's it. I would like to hand over to Gavin Young from Vodafone. Gavin, it's your turn.
Thank you, Marcus. Thanks for that. Welcome everyone to this morning's session. I'd like to give you an overview of Vodafone's journey towards this vision of a more universal fibre to the home future, but also to look at some of the technologies we're using as stepping stones on that journey to keep our customers happy as we embark on that journey. So first of all, let's start with a bit of context set in with our vision. Our vision is that not to have the fastest network. That's not good enough for our customers. Speed is necessary, but it's not so customers don't notice there's actually a network between their device that they're using and their content or application provider that might be on a server in a data center in the cloud somewhere. So to make that network invisible, we need more than just speed. We need capacity, so there's no slowdown in the busy hour. We need responsiveness. Michael mentioned at the start, low latency, particularly these new generation of interactive apps. And if there are issues, we want those to be hidden from the customer. So we want automatic resilience, failover, etc., to improve that reliability. And the key thing here is it's not just about the fiber to get to the customer's home. Most customers use Wi-Fi within their home. A few will connect some devices with Ethernet cabling, etc., or power line, but majority of devices are connected with Wi-Fi. So that performance must be sustained across the Wi-Fi as well. So that's the vision. If we look at how the broadband market has evolved, there's three kind of eras. I think that the first era was speed, where as we evolved from 500 kilobit to 2 megabit ADSL, and then 10 megabit and up to 100 megabits, at every increase in speed, that made an improvement for the customer that was noticeable. So their web page load times reduced. They could go from standard definition TV to high definition to 4K ultra high definition, and have that on multiple TVs in the home. And nowadays we're offering gigabit services over fiber and cable to our customers, and really we're offering more speed than many customers are using today. The next era was capacity, where with the rise of the streaming media and streaming video, video content can make up 80% of the traffic on many operators' networks. So you need the capacity to contain that, and combine that with the pandemic that triggered more people to work from home and use video conferencing. Although individually video conferencing bandwidth requirements are quite modest, but when you add that up across thousands and millions of customers, that adds up to a lot of capacity. So it's important not just to have the end speed that connects the customer with the access, but you need the capacity in the network so you don't get that busy hour slowdown that can frustrate customers. And then finally, as Michael alluded to, we've got a new era of applications. It's not just cloud gaming or keen gamers. There's metaverse-like applications. There's people like Google with their Beam, I think it was formerly Starline, kind of 3D video conferencing. There's people doing networked music collaboration. There's all sorts of new and interesting applications that require really kind of real-time responsiveness. You need to make the feeling of the network much more tactile now for these applications. So those are the three eras that we need to address in terms of shaping the technologies. So what's the state of the art today? And here I'm really talking about, Western Europe. And in Western Europe, a lot of operators who've been deploying fiber have shifted from GPON to XGS-PON technology, 10 gig symmetric. There are pockets of 25 gig. Certainly in China, there's deployments of early stages of 50 gig. And in Vodafone, we've tested all of these technologies. We did a press release last week in Czech on 25 gig, last year in Portugal on 50 gig. And a few years ago, we tested some early prototypes of 100 gig FlexPON. And beyond that, there's coherent PON that we're working on with folks like Cable Lab. So there's no shortage of evolution steps on the fiber journey. The expensive part is putting the fiber in the ground, but the technology roadmap is a lot of capability there. But as I said earlier, it's important that you have the Wi-Fi system capacity to match that. And the good news is this looks like potentially these things are not too out of step here. So the latest generation of Wi-Fi that's been deployed is Wi-Fi 7, and that can give you plenty of capacity in a modern home with lots and lots of devices and so on. So these technologies are reasonably well in step in terms of their roadmaps. And just to emphasize the importance of having modern Wi-Fi on the end of your fiber connection, there's no point in paying out for a high-speed fiber connection if you've got legacy old Wi-Fi on the end of it. So here we're showing 6 different operators and the mix of different Wi-Fi that they've got in this particular network. References at the bottom there, and you can see that Wi-Fi 7 is delivering higher speed through those fiber connections than Wi-Fi 6, which in turn is better than Wi-Fi 5, and that's better than Wi-Fi 4. So the message there is try and get your customers on Wi-Fi 6, Wi-Fi 7, Wi-Fi 6E, and get them away from legacy Wi-Fi, and they'll get a lot more out of that fiber connection. Okay. So in terms of deploying fiber to the home, it's a great technology, but it certainly has some challenges that impact the business case. And that's especially true in rural areas. And there are other hotspots as well. So challenges around the sparser customer density that makes the number of people you can sell that infrastructure to a lot less. There are longer distances to dig in rural areas, and that increases the deployment time. And the connectivity and infrastructure in those locales can be less reliable. Now, that might mean fiber is on poles instead of in ducts, or local power facilities in some countries can be less reliable in those areas. And the net effect of that is that the cost per home can be, a factor of 10 more than in urban or suburban areas. So that last 5 or 10% is often the target for government subsidies, because it's quite hard to make a business case to work in those areas. So what augmenting technologies can improve the existing broadband connection in those areas? And the attributes I'm looking at here are speed, capacity, responsiveness, and reliability. As we journey towards this vision of more universal fiber to the home, what tools have we got in the toolkit to keep customers happy and improve their broadband as we embark on this journey that can take a while, because of the reasons in the slide there. So let's look at each of those in turn. So first of all, speed. As a converged operator, we have mobile capabilities as well as fixed. So one of the things we've deployed in one of our countries is fixed mobile bonding, or hybrid access to give it its modern name, which is where a customer is connected by both fixed and mobile. And the default is for traffic to flow down the fixed line. But if that traffic bursts and exceeds the demand that can be satisfied with the fixed line, then the traffic can spill over, if you like, into the mobile connectivity. And software in the Vodafone router, the CPE there, and in our network on a containerized software on a virtual machine there, that bonds that traffic together and to give that a seamless, higher speed experience to our customers. So that can address the speed issue. For example, if customers got a 4 megabit slower DSL line and would like something faster. So that's been deployed for a while, and that's working very well. Let's look at capacity. Now, this is a plot. The reference there is from Plume, some data they published last year, comparing 4 different technologies. So we've got fiber, DOCSIS cable, satellite, and fixed wireless access. And this shows the download speed, how it's varying with time of day. And what you see here is that the wireline technologies, fiber and DOCSIS cable, are pretty similar. They're pretty flat. They've got enough performance and capacity, etc., to give that more predictable, reliable performance throughout the 24-hour period. Whereas both the fixed wireless access and the satellite technologies, these got a higher degree of sharing. And so what happens there is you get great speed at 4 a.m. In the morning. That's the peak speed. But in the evening busy hour, when more people are online and sharing that infrastructure, the speed per user can drop significantly. So that can be a challenge, because that means it's less consistent, less predictable. And this kind of mechanism is under threat if we get more and more live video delivered over these broadband networks. And the chairman of the BBC has previously mentioned that they believe they'll be taking most of their content from over-the-air delivery and delivering it over networks sometime in the 2030s. So if that happens, you get a huge uptick in the amount of real-time video traffic that's going out to customers over networks. That could cause a real problem for these capacity-constrained technologies. So one of the things we're looking at there is a technology called MAUD, or multicast-assisted unicast delivery, and this can be a way of more effectively using the network capacity to distribute live broadcast type content. So that's something we're testing at the moment. Now, if we look at responsiveness, there's a technology called L4S, or low latency, low loss, scalable throughput. And this is a standard that's published by the IETF. And this can really reduce the delay for real-time interactive applications over networks. And here we're showing some results that we published last year in a press release from some lab testing we did in Newbury. We're now trialing this live in one of our networks. And you can see in the middle column there, we've got a passive optical network, and you can see the latency improvement of the L4S categorized traffic versus non-L4S. And you may think, well, on a fiber network, surely fiber has got low latency. It's responsive anyway, and it's good at the physical layer, but the contention occurs at the packet layer, and you can still have micro bursts of flashes of customers, making demands at the same time. It's really, useful for a range of technologies. It can be applied to mobile, DSL, cable, etc. And I demonstrated it actually with fiber here, just to make the point that even fiber can be improved. So this is something that can make our broadband intermediate infrastructures more responsive as well. And then we've got reliability. So as a converged operator, we can provide mobile backup. So should that fixed line fail for any reason, we can keep the customer connected via mobile. So 3 ways of doing that. The first one is a dongle that you simply plug into your router, and we've got that deployed in a number of countries. Slightly higher performance is a flying lead antenna, where the antenna there, the little disc shown in the box, that's got a lead connected into your home router, and you can then put that on your windowsill to get better mobile reception and better speed. And the final one, something we've launched in one of our countries, is actually to use customers' smartphones, because that massively reduces the cost of offering this. There's no additional bill of materials for an antenna. You can use, particularly 5G dongles are not cheap, but if the customer's got smartphones in the house, then all their devices remain connected to their router, but the router changes the network connection path from a broken fixed line to the mobile and then out to the network. And if that mobile, the battery runs down or the signal gets weak, it can change over to another mobile in the household that's got a better signal. And this can cut over with some access technologies in a matter of 2 or 3 seconds very quickly. So that's something we've deployed, and that's getting good traction as well. And finally, on reliability, don't forget about power. So we talked about the reliability of the network connection. If that breaks, how can we mask that from the customer? But also power can be a problem as well. So one of the things we've launched in the UK, this was several months ago now, was a power backup capability, and this power backup device can power the fibre to the home ONT and the customer's Vodafone router and keep them going for 4 to 7 hours, and that's much more compact than a typical universal UPS uninterruptible power supply. And you can also actually use it for topping up your smartphone battery as well. So don't forget about power. Okay, and the final slide in this area of tools in the toolkit is around what we can do in our cable network. So cable is a very capable connectivity medium. It's capable of multiple gigabits. We're using that today to sell gigabit services to our customers. And it's often called an HFC network, a hybrid fiber coax network. And the F in HFC, the fiber, actually makes up most of those networks. So if we wanted to evolve our cable network to fiber, we don't need to completely overbuild the whole lot. We already have cabinets in the street that act as the demarcation between the fiber and the coaxial cable. And in that cabinet, we have equipment that we can plug in a fiber to the home, an OLT, an optical line terminal, on a little pluggable module. And that particular module shown there, that can deliver XGS-PON that can be shared across 128 customers, and we can plug 2 or 3 of those in. So we can use that existing cable cabinet as a launch point to get fiber to the home. So we call this fiber islands. We can do this much more surgically and much more quickly. And we demonstrated this at this year's Angacom event a few weeks ago in Germany. Okay, and just as the last slide, so that's an array of technology tools that we can use on this journey. But just because fiber is better, it doesn't give it an automatic right to win when it comes to take up. Customers might choose a technology that's just good enough if the price is better and the customer service impresses them. So on the left there, again, going back to the Plume data, the 4 technologies, 4 dimensions there: availability, reliability, consistency, and speed. And again, cable and fiber, wireline technology is very good, but the satellite and FWA, not so good technically. However, on the right is a JD Power survey of customer satisfaction in the US. And it shows that actually those so-called technically inferior technologies like 5G FWA are often, keeping customers happy, because if they're good enough and the package is right and it's a very flexible contract, then maybe customers will go for that. So really, to drive fiber to home take up, service providers need to make the entire product service wrap compelling. But the good news is we can make fiber even better. We can augment it with mobile backup, power backup, and L4S as well. Okay, so with that, I will hand over to Mohammed.
Thanks, David. Welcome, everyone. So my presentation is a little bit, we'll be focusing on some of the network considerations for multi-technology aspect on advancing broadband network for all, very high-level considerations. So for us as operator in North Africa, we have spent recent years massive investment in deploying broadband network nationwide. The Algerian territory is very vast and contains very diverse geographic footprints. So the deployment of fixed broadband and broadband in general is a little bit challenging, but we've made significant investment in recent years in access, particularly deploying fiber to the home nationwide. So massive investment that in access that, of course, implied investment in other network layers. We invested heavily in DWDM transport network in order to accommodate the vast and increase demand for speed with 400 gigabit line speed DWDM transport, and also in addition to this implied also the investment in submarine capacities in order to have a smooth, upgrade of the entire piece of network. But as operator, we have seen evolution of optical access systems over the many years through various systems. We moved from A-PON, B-PON, G-PON. Now we are moving to 10G symmetric. The future is in front of us. The next few years, 50G PON. I think Marcus has referenced the 100 gig PON, 200G PON, VHSP, very high speed PON, which is actually under standardization in ITT. The good news is that there are some things that hasn't changed across the years. So the fiber network, we still use the G52 fiber single mode in the ODN. The passive optically split is still roughly around 3.5 dB per stage. The overall loss budget is still around 30 dB, so it's something that roughly hasn't changed depending on the ODN class you may deploy. The reach still 20 kilometer in the access, and so last one is coexistence. So the new generations of PON has, or have considered coexistence, which is very, very important aspect for operators in order to coexist. And the ITT is also leading into standardizing coexistence under G9805 standards. So all of these points are important for operator in general. So what has been changed, what has been, let's say, roughly constant over the years, and of course the focus for us is what next beyond 10G. So once we move towards 10G, so there is of course demand consideration, 10G PON, 10G symmetric PON. The vision is what comes next. Of course, there was a lot of debate on beyond 10G. So of course, the 50G PON is an already approved standard in RTOT, which is also still under revisions nowadays. We leverage, of course, as I said earlier, the existing GPON and 10G PON symmetric deployments. So coexistence will be another key factor for beyond 10G PON. The multiple ONUs line rates that can be allowed for 50G, for example, or speeds beyond 10G will be multiples with multiple wavelengths, of course. The wavelength spectrum. Cost is an important aspect. Cost flexibility when we will have multi-rate ONUs, for example, is important. That cost is being considered, and this factor is also true for beyond 50G PON for speed that are greater than 50G. Some key aspects that may introduce flexibility for operators, PON slicings, which allows some quality of service deployment and value-added services to customers from operator standpoint. This is something that it is important for the multi-technology deployment in the near future. Of course, this beyond discussion, beyond 10G PON is driving an entire ecosystem of vendors, integrators, pluggables, vendors, etc., that are participating into the standardization. It also allows for 5 times 10G symmetric PON speeds, but of course, 42G of usable capacity of speed beyond 10G. One element of this discussion of migration of multiple generation of PON technologies, whether we move from GPON to 10G-PON or from 10G to 50G, is coexistence. Very, very key for operators to leverage existing infrastructure. The ITT has considered maybe some scenarios for coexistence, which I trying to put forward for illustration. The right-hand side on the top, you can see that one of the coexistence needs and technical aspect is using wavelength coexistence using a splitter, an external splitter. So there is legacy PON which can coexist with new generation PON through the use of an external splitter deployed in the ODN. The middle one is the multi-PON module, which operator can consider using this scenario. In the OLT, you have the NPM module that can consider 3-gen coexistence. And then you can see that the ODN is serving 3 different generation of ONUs on the right-hand side. The last of the bottom, the PON systems coexisting with an external coexistence element, device, can be WDM mix and other coexisting element, which is in the left-hand side. You can see that there are a number of wavelength inputs to the existing element and a single aggregated output. Or this is generic coexistence element. But it is important for operators to consider while moving from multi-generational PON systems that coexistence is important. So there are a lot of technical details that can be debated here, but this is just an illustration of this important aspect. So I think the key element of my input to the entire discussion is that the migration scenario. So you know, it is important that for an existing PON systems that have been already being deployed to coexist with future generations of PON in smoother and you know, performed manner, not to cause crosstalk or impacting the existing quality of service of customers. So it is important to leverage the existing fiber infrastructure or the ODN network. Of course, moving to a higher generation of PON requires some upgrades of the ODN side and ONU's side. Of course, customers need to be migrated towards these higher speeds, and of course you know, subscribers need to be migrated. So we are trying to convince our subscribers, to the ones who are still in the copper-based broadband access systems, to move towards higher speeds, reliable fiber-based infrastructure. So of course, this needs to be moved into the new systems. These subscribers need to have new ONTs and etc. So, and the entire infrastructure needs to coexist in the same fiber infrastructure. This is it. Thank you very much.
Thank you, Mohammed, and to all our other speakers, and perfect timing, because we now are moving to the question and answer portion of our event. As a reminder, if you'd like to participate in the Q&A, please just type your question into the text box located to the left of the presentation window, or click on the Q&A icon at the bottom of your screen. If we're not able to answer all the questions that are submitted today, we'll be sure to share them with our speakers, and then we can get back to you offline. So with that, I'll move to our first question. I can see the questions starting to come in. And the first question goes to Marcus. And it is, why is there so much about satellite today, given your presentation and that, you know, fiber seems so superior?
Yeah, very good question. The key is, I think, the satellite option.
Can I just check with?
The fiber.
I think we've lost Marcus. So we'll come. Okay, I think Marcus is struggling from some of the issues that Gavin was talking about in terms of.
Yes, seems so.
Yeah, I think you're back now, Marcus. Are you okay to? On the first question was about the fuss about satellite today.
Yes, I mean, one thing is that satellite is a new kid on the block, so that's why people are getting very interested. The nice thing about satellite is really this very quick, fast, large coverage you gain. So as a first step, satellite is quite an option specifically for areas which are a bit underserved, which are more remote, where the infrastructure is not well built out. So that's why there is a lot of fuss. Just like a little bit of a warning. I mean, at one point, if you move to more satellite, more people joining the satellite, and Gavin's slide on the difference in satellite capacity over a day shows exactly the problem. If a lot of people are on the satellite access network, it sort of gets lower capacity and lower quality. I think that's the fundamental problem, and in the long term, that will even be getting a bigger problem. But satellite is a very good option for like very low bandwidth applications, like messaging or things like that. Is a very good option for exactly rural areas. So nothing against that, but in the long run, I don't think satellite will do the job.
Yeah. Thank you, Marcus, and apologies. I think the issue was at my side rather than your side, Marcus. So apologies for that. Okay, so new question for Gavin. I think this is a good one for yourself, or perhaps Mohammed. You may also have views. So for fixed line, besides using fiber optic, are you seeing any new materials that can provide higher speeds?
No, I think that's an interesting question. I think, you know, fiber itself can actually go faster in terms of, well, not speed per se, but lower latency with hollow core fiber. And then if you look at some of the you know, and installing the inter-satellite comms, you know, over a long distance, that could give you lower latency than fiber, so it could be higher performance in that context. So instead of going through a traditional fiber across the Atlantic, if you went via satellite with the inter-satellite comms that are, you know, the kind of almost free space optics kind of type approach, the propagation is quicker there, so it's faster in terms of the latency. And for things like, you know, trading desks trying to get an edge on making those trades, there could be niche scenarios of interest there. But I think, you know, fiber itself, we keep seeing records broken as people step up the speeds, you know, delivered over fiber, and so that seems to be, you know, the ultimate still. I'm not aware of any other materials. I'm sure there's some work going on in university somewhere and making fiber out of different materials, or you know, In the past, we moved on from waveguides to fiber, but compared to the speeds that are being deployed today over the fiber in the ground, research is showing, you just see what is done over transatlantic fibers and all that kind of thing, and somewhere down the line, some of those technologies then come into access. So coherent PON, for example, coherent techniques were used on long-haul transatlantic, and now we have work going on coherent PON. So I think there's a bit of a delay where the new techniques that may be more expensive to do, but pay off on a core network or an international network. And eventually, if those technologies can be cost reduced, maybe they can creep into access initially as an aggregation technology, and then maybe one day as a last mile technology. So it tends to filter down through the ecosystem that way. So I'd be inclined to look to technologies currently deploying and the speeds we're seeing on international networks, and see if those technologies like coherent techniques might eventually make their way to access networks.
Thank you, Gavin. Another question has come in. I don't know, Mohammed, if this is something that you could pick up, or if not, Marcus or Gavin, and that is, what is the future of fiber broadband against the progression of satellite communications like SpaceX? I guess just from your perspective, what do you see as the future for fiber broadband against satellite?
I don't mind having a... Go ahead, sorry.
Jake, jump on it. I saw work in 3GPP on terrestrial networks and the 5G component of satellite rising. So there was standardization efforts towards integration. It seems to be great opportunity for some markets. I also saw the IMT component of the high altitude platform, which integrate INT in ITU-R radio communication sector, where you have these high altitude platforms integrating INT, international mobile telecom component. So there is great opportunity for, I said, some markets with integrating broadband with satellite, but overall, I agree with Marcus. Fiber still there is great development in fiber aspect. Gavin's mentioned the multi-core fibers. There is work in ITT in space division multiplexing fiber, SDMs, which is a new innovation in fiber optics. Cables, you can see the work being done in ITU, as I said. And of course, we are leveraging coherent, right? Transmission, DSP-based receivers, transmitters, and advanced modulation formats. That's all these techniques, among others, are leveraging the fiber links for increased capacity, including AI for in the access. So I do, so our perspective, fiber is promising for high speed.
Thank you, Mohammed. I think we just got time for one more question. We'll see. But Gavin, can you give your perspective as a regional player just on the update of the copper sunset? Is that something that you're able to comment on in the different countries that you operate in?
Yes, certainly we've been proactively seeking to wind down DSL over the last few years and move customers onto cable and fiber. And sometimes when you reach a critical mass, remote exchange, it may be something, you've got somewhere you can, if there are a few residual customers, move them onto fixed wireless access, just so we can shut that down, because it doesn't justify the cost running a whole DSLAM and all the space and power if you've only got a handful of customers left. So it's something we've been proactively doing, and certainly a number of our countries in Western Europe have made great progress over the last few years. There are some challenging areas. So for example, in Greece, the Greek islands and so on, it's a bit more tricky there to connect folks up with newer technologies in some situations. But it's happening quite aggressively, and we have targets, and we're pushing ahead with that.
Great, thank you. So unfortunately, we're out of time. We did get a lot more questions, so we will try and get back to you offline. So if you have submitted a question, we will come back to you via email. Don't worry about that. But it's just left for me to thank Marcus, Gavin, and Mohammed for speaking today, for providing your time and your expertise. Thank you very much. And also thank you for our sponsors too. Thank you very much.